possible causes of water ingress can include a damaged or cracked service conduit. Water could be seeping into the conduit underground or at the top where it enters the pole. Another cause can be loose connectors on the pole. If the wire connections in the pole are loose, water could penetrate the insulation and wick down the wires. A faulty pole is yet another possible cause. The replacement pole may not be properly sealed or watertight, allowing moisture to enter. Condensate formation is another cause to consider. Moisture can condense inside the conduit or panel, especially during temperature fluctuations. To troubleshoot, firstly, inspect the conduit and pole. Check the conduit for damage or leaks and examine the pole's connections and fittings for any signs of water ingress. Secondly, tighten loose connections. Ensure that all wire connections on the pole are tight and waterproofed. Thirdly, check the pole for defects. Inspect the pole for cracks, holes, or other areas where water could enter. If necessary, contact the utility company for further investigation. Fourthly, install condensate traps. If condensation is suspected, consider installing condensate traps in the conduit or panel to prevent moisture buildup. Fifthly, dry out the wires. Use a hairdryer or fan to dry out the neutral wires where water is dripping. This will help prevent further wicking and damage. Sixthly, monitor the situation. Keep an eye on the panel and check for any signs of recurring water ingress. If the problem persists, consult with a qualified electrician. Additional considerations include the type of insulation on the neutral wires, which can affect how easily water wicks. Polyethylene insulation is more resistant to water penetration than cross-linked polyethylene. If the wires run a long distance underground, water can potentially wick from a distant source via capillary action. It is important to ensure that the panel is adequately sealed and ventilated to prevent moisture accumulation. Consider examining the service conduit for any signs of physical damage, such as cracks or punctures. These damages can create pathways for water to enter the conduit system, especially where the conduit transitions from underground to above ground. Closely inspect the area where the conduit enters the pole and the building, as these are common points for water to seep in. Pay attention to any signs of corrosion or rust on the conduit, which could indicate that water has been present for an extended period. When inspecting wire connections on the pole, look for any signs of looseness or corrosion. Even a small gap in the connection can allow water to penetrate the wire insulation. Ensure that all connections are properly tightened and sealed with waterproof connectors or tape. If you find any corroded connections, clean them thoroughly and apply a corrosion inhibitor before reassembling. Faulty poles can also contribute to water ingress, especially if they are not properly sealed or if they have cracks or holes. Inspect the pole for any visible defects, particularly near the top where the service wires are connected. If you notice any damage, contact the utility company immediately, as they are responsible for maintaining the pole's structural integrity. Condensation is another potential source of water in the electrical panel. Temperature fluctuations can cause moisture to condense on the inside surfaces of the conduit and panel. This condensation can then drip onto the wires and other components, leading to corrosion and electrical problems. To minimize condensation, ensure that the panel is properly ventilated and consider installing a dehumidifier in the electrical room. When drying out the wires, use a hairdryer or fan on a low setting to avoid overheating the insulation. Do not use a heat gun, as it can damage the wires. Allow the wires to dry completely before restoring power to the panel. To prevent further wicking, consider applying a sealant to the ends of the wires where they enter the panel. Use a sealant that is specifically designed for electrical applications and is compatible with the wire insulation. Regularly monitor the panel for any signs of water ingress, especially after heavy rainstorms or periods of high humidity. If you notice any recurring problems, consult with a qualified electrician to determine the underlying cause and implement appropriate solutions. Remember that the type of insulation on the neutral wires can significantly impact their ability to resist water penetration. Polyethylene insulation is a non-hygroscopic material. Cross-linked polyethylene insulation is a hygroscopic material. If you suspect that water is wicking from a distant source via capillary action, consider installing a drip loop in the service wires near the panel. A drip loop is a section of wire that is bent downward to create a low point where water can collect and drip off before it reaches the panel. Ensure that the drip loop is positioned so that water drips away from the panel and other electrical equipment. Panel sealing is a crucial aspect of preventing moisture accumulation. Inspect the panel for any gaps or openings where water can enter. Seal any openings with weatherproof caulk or sealant. Pay particular attention to the areas around the conduit entries, the door, and any other access points. Proper ventilation is essential for preventing condensation inside the panel. Ensure that the panel has adequate ventilation openings to allow air to circulate freely. If the panel is located in a confined space, consider installing a fan to improve air circulation. It's also crucial to check the grounding system for any issues that could contribute to the problem. A faulty grounding system can create electrical imbalances that attract moisture. Ensure that the grounding wires are properly connected and that there are no signs of corrosion or damage. If the problem persists, consider having a professional electrician inspect the grounding system. Another area to investigate is the possibility of galvanic corrosion. This type of corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as water. The corrosion can then spread to other parts of the system. To prevent galvanic corrosion, use compatible metals for all electrical connections and apply a corrosion inhibitor to any dissimilar metal junctions. If you suspect that the water is entering the conduit through the top where it connects to the pole, consider installing a weatherhead. A weatherhead is a fitting that is designed to protect the conduit from rain and other elements. Ensure that the weatherhead is properly installed and sealed to prevent water from entering the conduit. In addition to inspecting the conduit and connections, also check the surrounding area for any potential sources of water. Look for leaky pipes, overflowing gutters, or other conditions that could contribute to the problem. Correct any identified issues to eliminate the source of the water. If you're unsure about any aspect of the troubleshooting process, it's always best to consult with a qualified electrician. They can provide expert guidance and ensure that the electrical system is safe and reliable. Always prioritize safety when working with electricity. Turn off the power to the panel before performing any inspections or repairs. Use appropriate personal protective equipment, such as gloves and safety glasses. And never work on electrical equipment in wet conditions. Consider the impact of soil conditions on the underground conduit. Highly corrosive soils can accelerate the degradation of the conduit and increase the risk of water ingress. If the soil is known to be corrosive, consider using a more durable type of conduit, such as PVC-coated steel. Another important factor to consider is the slope of the conduit run. If the conduit slopes downward towards the panel, it can create a pathway for water to flow directly into the panel. To prevent this, ensure that the conduit slopes away from the panel or install a drain at the lowest point of the run. Evaluate the use of sealants and tapes for waterproofing connections. Choose products that are specifically designed for electrical applications and are compatible with the materials being joined. Follow the manufacturer's instructions carefully to ensure proper installation and sealing. Consider the impact of temperature variations on the conduit system. Expansion and contraction due to temperature changes can create stresses that lead to cracks or leaks. To mitigate these effects, use expansion fittings and flexible conduit connectors to accommodate movement. Pay attention to the presence of any animals or insects that could damage the conduit or wiring. Rodents, for example, can gnaw on insulation and create openings for water to enter. Take steps to control pests in the area around the electrical system. Ensure that the electrical panel is properly labeled to identify the circuits and components. This will make it easier to troubleshoot problems and perform maintenance in the future. Keep a detailed record of all inspections, repairs, and modifications performed on the electrical system. This information will be valuable for tracking trends and identifying potential problems before they become serious. Consider implementing a regular maintenance program for the electrical system. This program should include periodic inspections, cleaning, and testing to ensure that all components are functioning properly. If you are not comfortable performing electrical work yourself, consider hiring a qualified electrician to perform the maintenance program. Remember that electrical systems are complex and potentially dangerous. Always prioritize safety and consult with a qualified professional if you have any doubts or concerns. Consider using thermal imaging to detect temperature differences in the panel and conduit. This can help identify areas where water is entering or where connections are loose. Thermal imaging can also be used to detect overloaded circuits or other potential problems. Evaluate the use of surge protection devices to protect the electrical system from voltage spikes caused by lightning or other events. Surge protection devices can help prevent damage to sensitive electronic equipment and reduce the risk of electrical fires. Consider the impact of vibration on the electrical system. Vibration can loosen connections and cause damage to components. If the electrical system is located in an area with high vibration, use vibration-resistant connectors and supports. Pay attention to the condition of the weather stripping around the panel door. Damaged or deteriorated weather stripping can allow water to enter the panel. Replace the weather stripping if it is no longer providing a tight seal. Consider the use of a drip pan or other containment device to catch any water that may enter the panel. This can help prevent water from spreading to other components and causing further damage. Evaluate the use of a corrosion inhibitor to protect metal components from rust and corrosion. Apply the corrosion inhibitor to all exposed metal surfaces, including connections, enclosures, and supports. Consider the impact of electromagnetic interference (EMI) on the electrical system. EMI can disrupt the operation of sensitive electronic equipment and cause malfunctions. To mitigate EMI, use shielded cables and connectors and install filters on power lines. Pay attention to the condition of the conduit supports. Damaged or deteriorated supports can allow the conduit to sag or shift, which can create stress on connections and increase the risk of water ingress. Replace any damaged supports. Consider the use of a waterproof enclosure for the electrical panel. This can provide an additional layer of protection against water and other elements. Ensure that the enclosure is properly sealed and ventilated. Evaluate the use of a remote monitoring system to track the performance of the electrical system. This system can provide alerts if there are any problems such as water ingress, voltage fluctuations, or temperature changes. Remember that the electrical system is a critical part of the building infrastructure. Regular maintenance and inspections are essential for ensuring its safe and reliable operation. Contact a qualified electrician if you have any questions or concerns about the electrical system. Ensure all conduit fittings are properly tightened and sealed. Loose fittings can allow water to enter the conduit system. Use appropriate tools and techniques to tighten fittings to the correct torque. Consider using a sealant or thread sealant on conduit fittings to prevent water from penetrating the threads. This can be especially helpful in areas with high moisture or humidity. Check for any signs of improper grounding in the electrical panel. Improper grounding can create electrical imbalances that can attract moisture. Ensure that all grounding connections are secure and properly sized. Evaluate the condition of the grounding electrode conductor GC. The GC connects the grounding system to the earth. A damaged or corroded GC can compromise the effectiveness of the grounding system. Consider using a ground rod driver to install ground rods deeper into the earth. This can improve the effectiveness of the grounding system, especially in areas with poor soil conductivity. Check for any signs of standing water around the electrical panel. Standing water can indicate a drainage problem or a leak. Correct any drainage problems and repair any leaks to prevent water from entering the panel. Evaluate the effectiveness of the building's lightning protection system. A properly installed lightning protection system can help protect the electrical system from damage caused by lightning strikes. Consider using a surge arrestor to protect the electrical panel from voltage spikes caused by lightning strikes. Ensure that the surge arrestor is properly grounded and connected to the electrical system. Check for any signs of nesting animals or insects inside the electrical panel. Animals and insects can damage wiring and create pathways for water to enter the panel. Remove any nests or infestations and seal any openings to prevent future problems. Evaluate the condition of the panel door gasket. A damaged or deteriorated door gasket can allow water to enter the panel. Replace the door gasket if it is no longer providing a tight seal. Consider using a desiccant inside the electrical panel to absorb moisture. A desiccant can help prevent condensation and corrosion. Monitor the desiccant regularly and replace it when it becomes saturated. Check for any signs of corrosion on the electrical components inside the panel. Corrosion can damage electrical components and create a safety hazard. Clean any corroded components and apply a corrosion inhibitor to prevent future corrosion. Evaluate the condition of the bus bars inside the electrical panel. Bus bars are conductive bars that distribute electricity throughout the panel. Damaged or corroded bus bars can compromise the integrity of the electrical system. Contact a qualified electrician to inspect and repair any damaged or corroded bus bars. Consider using a dielectric grease on electrical connections to prevent corrosion. Dielectric grease is a non-conductive grease that helps to seal out moisture and prevent corrosion. Apply dielectric grease to all electrical connections inside the panel. Check for any signs of loose wiring inside the electrical panel. Loose wiring can create a safety hazard and can also cause electrical problems. Tighten any loose wiring connections to ensure that they are secure. Evaluate the condition of the circuit breakers inside the electrical panel. Circuit breakers protect the electrical system from overloads and short circuits. Damaged or malfunctioning circuit breakers can compromise the safety of the electrical system. Test circuit breakers periodically to ensure that they are functioning properly. Consider using arc fault circuit interrupters as size to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. A size can detect arc faults and shut off the power to the affected circuit. Check for any signs of overheating inside the electrical panel. Overheating can indicate a problem with the electrical system, such as an overloaded circuit or a loose connection. Use a thermal imaging camera to check for hot spots inside the panel. Contact a qualified electrician to investigate and repair any overheating problems. Consider using a power quality meter to monitor the electrical system. A power quality meter can measure voltage, current, frequency, and other electrical parameters. This information can be used to identify potential problems with the electrical system. Ensure that the electrical panel is properly labeled and that all circuits are clearly identified. This will make it easier to troubleshoot problems and perform maintenance on the electrical system. Keep a record of all electrical work that is performed on the electrical system. This record should include the date of the work, the type of work performed, and the name of the electrician who performed the work. Store this record in a safe place and make it available to future electricians who may need to work on the electrical system. Consult with a qualified electrical engineer if you have any questions or concerns about the electrical system. An electrical engineer can provide expert advice and design solutions for complex electrical problems. Remember that electrical safety is paramount. Always follow safe work practices when working with electricity and consult with a qualified professional if you have any doubts or concerns.